Hey guys, today we will be discussing a Google interview question wherein you will be asked to shuffle the elements of a given array. So let's go ahead and try to understand the problem statement. So it states that you will be given an array nums consisting of two n elements, and this will be the form of the array such that it will be x1, x2 until xn, and the next half will be y1, y2 until yn. So as you can see that since the length of the array is 2n, so from x1 until xn is the first half, while y1 until yn is the second half of this array. Now as an output, you have to return the array by shuffling the elements in a way that the output array will consist of elements as x1, y1, x2, y2 and so on until xn, yn. Now to better understand this question, let us have a look at an example. So let's say that this is the given array. Here the length of the array is 2n. So n is 3. That means 2 here is x1, 5 is x2, 1 is x3. Now 3 is y1, 4 is y2 and 7 is y3. So the expected output should be x1, y1. That means 2, 3. Then x2, y2 which is 5, 4. And then x3, y3 which is 1 and 7. So this is the expected output. Now, I hope that with the help of this example, you have a clear idea about what this question asks you to do. Now, moving on to the solutions, I will give you two solutions to this problem, and both solutions will have a linear time complexity. That is, at the worst case scenario, you have to traverse the array only once. So, without further delay, let us dive into the first solution. Now, as we have done so far, before diving into the code or the solution directly, we will first have a look at the solution with the help of an example. That way, we will be able to visualize the approach that we will be following, and then we will implement it as a code. So let's say that this is the given array to us. Now in this approach, we will take the help of couple of arrays such that we will break the given array into two parts. The first array will store the elements contained within the X cities or in the first half of this array, while the second array will store the elements in the second half of this array. That is, this array has a length of 6. Therefore, the given value of n in this case is 3. Hence, we will use two more arrays to store 2, 5, 1, which will be x1, x2 and x3 respectively. And then in the next array, which will be y, will store the elements 3, 4 and 7, which are y1, y2 and y3. So let's have a look at the following presentation. After creating the two arrays, let's say that this array is x and this one is y. We will iterate over each element in each array such that in every iteration, we will extract the value from the respective indexes of both the arrays. So that means in the first iteration, when we are at the first index, then in the array X, the value is 2, while the value in the first index in array Y is 3. So we will extract both these values and then store them in another array which will store the output. So in the first iteration, it will store 2 and 3. Then we move on to the next iteration and we will simply store the element stored within the second index of both the arrays, that is x and y, which stored the values 5 and 4 and then stored them in our result array at the same time. Then we move on to the third iteration where we simply go ahead and store the values at the third index within both the arrays, that is x and y, and then store these values in our resultant array such that 1 and 7 get stored in our resultant array simultaneously. With that, we come to the end of our iteration. And now if you want to know how long do we iterate, if you have a close look, then you'll find that we are undergoing 3 iterations. So what is 3? 3 is nothing but the value of n. So we iterate within the range of n. And that way it will also help us to keep account of every index for both the arrays, that is x and y, simultaneously. And then we will use it to store the values in our resultant array. And finally, once we have shuffled all the values properly, we will simply go ahead and return this as an output. So without further delay, let us go ahead and execute this in our code. So as we discussed, let's say that this is the given array. Now we will create two more arrays. Let's say that these arrays are x and y. Now X will store the values 251. So how do we store the values 251? Now, please note that I am taking this example just to explain you, but X will always store the values in the first half of the array, while Y will always store the values in the second half of the array. So how do we do that? To do that, we simply need to go ahead and split our array in a way that X stores the first n elements and then Y stores the next n elements. So the given value of n in this example would be 3. Hence, we simply go ahead and split this array in a way that X will store all the elements starting from 0, that is from the index 0 until the index n. Then Y will store the values which start at the index n and then store all the elements until the end of the given array. And what's the array in this case? It is A. So this is how we simply go ahead and split the given array into two parts. We also need another array where we will store the result or the output. So let's say that the name of that array is result. Now please note that since this is Python, it is nothing but a list and we are simply splitting the list into two parts. So result is an empty list at this point of time. Now we need to begin a for loop in order to iterate over the elements of X and Y respectively and then store the values within the result array. So we simply go ahead and define a for loop for I in range and then we iterate until the given value of n. Before we move ahead, let's visualize what X and Y stores. So X here stores 251 while Y here stores 3, 4 and 7. Thus, when we iterate within the range n, we can easily iterate over each element within both the arrays, that is X and Y. Since X is 3, so we can traverse through all the indexes of X and Y one by one. Now we simply go ahead and append the values to the result array. So we will be using the append method here to append or add the values to the result array. First, we have to add the value at the respective index in X. So we say result.append and then we specify the value stored within our list or array X with the help of I, which is the counter that keeps a count of each index. Once we append the value of the array X, it's now time to append the value of Y to the array result. So once again, we use result.append and then the value at the ith index within the Y array or the Y list. With that, we are done with our for loop and finally we simply go ahead and return the result array. Okay, that's how simple this code was. Now let's go ahead and execute our code upon a few test cases that have been given to us and let's find out if this works. So these are the test cases that have been given to us. Now let's go ahead and execute this piece of code. And there we go. As you can see that the expected outputs and the outputs that we received are exactly the same. Hence, this code works perfectly fine and you can definitely use it if this question appears in your interview. Also, it is quite evident that you are iterating over the range n. Hence, the time complexity of this approach is linear. That is, this approach has a time complexity of n. With that, we come to the end of the first solution. I will now go ahead and demonstrate another solution using which you can solve this question. And in that solution, you do not need to create separate arrays or separate lists to reach the final output. You only have to use couple of pointers which you can shift within the given array itself and reach the final output. So let's have a look at that method now. So as I mentioned, we will take the help of couple of pointers in this approach. Let's see how we can use these pointers to shuffle the elements of the given array. Now please note that we are once again using the same example wherein x1, x2 and x3 are 251 while y1, y2 and y3 are 3, 4, 7. However, in this case, we will not split our array or we will not create two separate arrays in order to shuffle the elements. Instead, we will use two pointers. Let's see how we will do that. So we will once again iterate within the range of n, and n here is 3. So we will iterate within the range of 3 in this example, such that we will use two pointers I and j. Initially, I points at index 0, which has the value 2, and j points at the index 3, which has the value 3. Now, this also means that I and j point at the values which will be deposited within our resultant array in the first iteration. So that would mean that the resultant array will consist of the values 2 and 3 in the first iteration. So we simply go ahead and populate the values 2 and 3 within our resultant array. Then we move on to the next iteration such that we shift the pointers I and j by 1 unit. That is, I will move on to the first index while j will move on to the fourth index. So as you can see, I moves on to the first index which holds the value 5, while j moves on to the fourth index which holds the value 4. Now, if you have a close look, then you'll find that there's a relation between I and j. When we shifted I to 1, j shifted to 4. This means the value of j is equal to I plus n, wherein n is 3. So initially j was 3, which is equal to n. Hence, we can also say that j in the next iteration becomes I plus n or I plus j. That is, previously j was 3. So j now becomes I, which is 1 plus 3, that is 4. So once we have shifted these pointers, we simply go ahead and store 5 and 4 within our output array. So our output array now stores 5 and 4 in the second and third index. Finally, we go ahead and shift I and j by 1 unit once again. That means I will move on to the second index while j will move on to the fifth index. That would also mean that if I points at the second index and j points at the fifth index, it is based on the relation that j is equal to I plus n or I plus j. So I is 2 and j was 3. So 2 plus 3 now becomes 5. Therefore, I points at the second index which has the value 1, while j points at the fifth index which has the value 7. So we simply go ahead and store these values within the resultant array. This also means that we have traversed through the entire list or the entire array, since we will be traversing within the range of n, and when I points at the second index, then that means we have already traversed within the range n. That is because the length of this array is 2n and n is 3. That means we have reached the final output and we have successfully shuffled the values as given in the question, and we simply return this output array as an answer. So now let's go ahead and let's find out how we can implement this in our code. Here we have the function shuffle underscore array, which has the arguments a and n. Here a is the array that has been given to us. Now let's go ahead and initialize our pointers I and j such that I points at the index 0 and j points at the index n. We also need an array to store the result. So let's say that the name of that array is res. Now we need to go ahead and use a for loop in order to iterate within the range of n. And now let's go ahead and append the values to our resultant array res. So res.append. And let's go back and let's have a look what was happening in our illustration. So as you can see that the first value within our resultant array was the value at the index pointed by I. So we simply go ahead and append the value pointed by our pointer I. The second value was the value that was pointed by j. And what was j? J was nothing but I plus j in every iteration. So even if you have a look in the first iteration, then you'll find that j is equal to I plus j. And why so? That is because I is 0 and j is 3. So 0 plus 3 is 3. That means j points at the index given by I plus j, which is 0 plus 3, that is 3. So this means we have to use our append function and then append the value that is pointed by I plus j in our given array. This operation continues until the end of this for loop. And once we are done with our for loop, we have our resultant array and we simply go ahead and return. So what was our resultant array? It was res. And that's it. With that, we come to the end of this code. And now it's time to go ahead and check if this works by implementing this code upon the test cases that have been given to us. So the test cases given to us were these. Now let's go ahead and execute this code. And there we go. The outputs that were expected and the outputs that we received are exactly the same. So we can safely say that yes, this algorithm or this piece of code works, and you can definitely use it in your interview if you come across this question. Also, since we are once again iterating within the range n, so this algorithm also has a time complexity of n, that is a linear time complexity. And as you can see that we have not created any other list or array in this case to reach the final output. You can further go ahead and simplify this piece of code, since as you can see that we do not actually need these I and j pointers outside our for loop. I used them specifically to explain you how this works, but you can simply go ahead and eliminate these pointers and simply use your for loop to reach the final output. And what was j? J was nothing, but it was storing the value of n. So this will also yield you the exact output that you need. So let's execute this once again. And there we go. As you can see, we have further optimized our code and reached the final solution. With that, we come to the end of this interview question. I hope it helped you. If you have any queries, please mention them in the comments below, and I will try my best to answer all your queries. Goodbye.